Howdy, I'm Dave Noderman. Today I'm going to be building a Tesla coil design called a Slayer Exciter.
Here you can see a schematic for the Slayer Exciter. It has a power source, a resistor, a transistor, primary and secondary coil, and the capacitor symbol at the top of the secondary just represents the small capacitance with air. Now as current starts flowing through this circuit, it'll diverge before the resistor, but it can't go through the primary coil since the base of the transistor is not powered. The transistor is acting like an open switch. So what will happen instead is that the current will flow to the base of the transistor, opening the gate and allowing current to flow through the primary to ground. Well, as this happens, the primary coil will create an electromagnetic field, which will be induced into the secondary, creating a current in the opposite direction. This will cancel out the current going to the base of the transistor, causing the electromagnetic field on the primary to collapse and the entire process to start over. The design of the Slayer Exciter needs a resistor. It can range anywhere between 10,000 and 100k ohms. These ones here are 47k ohm resistors, and if you buy them in bulk, you can get them a lot cheaper than if you just buy a few. So there's a pack of 100. This is magnetic enameled copper wire. It's what I'm going to use to wrap my secondary coil. It's going to be this PVC pipe, which I'm going to wrap the copper wire around. I'm going to use this smaller piece of PVC to wrap my primary coil, since it fits tightly around the secondary coil. You should also be sure to have some braided wire on hand. The integral part of the design are these transistors, TIP31C transistors. They will oscillate, which will provide your circuit with an alternating current. In order to supply power, you should use at the minimum a 9-volt battery. However, I personally prefer my power supply. At long last, I have finished winding my primary and secondary coils. My primary coil has about 3.5 winds, and my secondary coil has, I estimate it to be around 750. I was also sure to use sandpaper on either terminal end of my wire, so that I could get a good connection when I'm going to solder. I'll test that now with my I'm going to measure resistance using my multimeter, just to make sure that there aren't any breaks or gaps, which there aren't. Anyway, to mount everything, I'm going to use this space made out of scrap wood that I found. I drilled an 1.5-inch hole through it, that's the same diameter as my secondary coil, and I did that using this sawtooth drill bit, which I was lucky enough to find in one of our toolboxes. I count myself lucky every time I find something in one of the toolboxes. It's not as snug as I had hoped for, but a little glue should be able to fix that up later. The primary coil sits around the secondary coil. Now I'm just about ready to begin soldering, and I think I'll use these angle brackets I found to solder things together. I'll run the resistor in between them and solder wires to either one respectively. Lastly, once I'm done with that, I'll screw on the switch to the edge, which will cut the ground wire so that I can turn the circuit on and off by cutting its connection to ground. Now I think it's time to begin soldering.
The first time I tried powering it up, I had high hopes that it would work, but it didn't.
Here we go. Well, it should be on.
And it has to do with the direction of the primary and the secondary coils. They each need to have the same direction if you want the Slayer Exciter circuit to work properly.
I'm ready to test my hypothesis concerning the direction of the windings on the primary coil. I've done a little bit of rewiring, so now the gradient of the windings in the primary is the same as the gradient of those in the secondary. That is to say, the coil is rising as it goes around counterclockwise. So, I'll start by putting my transistor in the transistor slot that I've made. And now we can see if my Slayer Exciter excites and slays. And excite it does. Now that the coil is done, I shall turn it on. The first thing I see is the stream of electrons that's coming off the end of the secondary coil. It's not particularly dangerous to... I've noticed an anomalous consequence of running my Slayer Exciter over in my workspace, which is also a laundry room. So I think I'll be able to quickly demonstrate this by turning on the Slayer Exciter. And now our dryer is on the fritz. And completely unresponsive to all forms of button pushing. Except that. Where the heck is the shut up button on this thing? So I want to see how much energy that stream of electrons puts out. And I have this standard paper towel. As you can see, it started it on fire. This was a bad idea. This jet of electrons that comes off should be providing a very small force. And I think I'll be able to demonstrate that with my lighter. If I hold it near the jet of electrons, you can see that the flame is being warped by the jet of electrons itself. The field being created by that coil can excite the gases inside a fluorescent lamp. The secondary coil is expending energy to make this glow, and I can cut that off by moving my hand in between the coil and the light. This is just a simple incandescent bulb. It's filled with argon, xenon, and some other gases. If I hold it up to the secondary coil, it excites those gases as well, and I am seeing sort of a purple-orange aurora being created. So here's something I don't get. These TIP31C transistors, they're supposed to be rated for 100 volts at up to 6 amps. Yet, when they're in the Slayer Exciter and I have the voltage, say, over 15, all of a sudden they do that. Oh. Why is that, I wonder? I suppose it's possible that every single one of these transistors in my very large pile of now dead transistors has simply been a factory dud, although I think it's something that has to do with my design more than it is that. I suspect that it might be caused by the high voltage on the secondary coil, but I can't be sure. So I think I've engineered a solution. This wire is an extension cable for what I already have, except the wire that goes to the base of the transistor, I've soldered in a 100 ohm resistor. Let's see if this prevents my transistors from dying at such low voltages. Let's start it low. I don't want it to be a repeat of my first failed attempt. 18, 19... Let's say around 10 volts. I guess it's about the same as it was. Let's go higher. Past 15. Promising. Oh, crap. There's a lot less that I can do to prevent the transistors from heating up, and that's because of this circuit design. It doesn't output a nice sinusoidal wave, rather it outputs what's closer to a square wave. And the secondary coil is only active while the current is changing through the primary coil, which means that while the current is plateaued, that's just straight direct current going through my transistor causing it to heat up. And I could try and prevent that by using something that can handle more current, like a MOSFET. And I've also seen some designs that use multiple transistors to try and keep the current changing, although I'm not going to get into that with this. I'm now finished with my design. The last thing I did was use electrical tape to hold a 9-volt battery onto the side. And each terminal has alligator clips which can go into the design. That leaves it open in case you want to supply it with any other source of power. All that need to be done now is flip the switch, and the Slayer Exciter is active. Albeit not very powerful, only being powered by a 9-volt battery.
You know, I gotta say, despite its small size, the Slayer Exciter certainly delivers. Now this Tesla coil, this one's only the warm-up band. The real Tesla coil is yet to come. Well, I certainly hope that you found this informative and entertaining. If you did, you can like the video. If you didn't, you can do nothing. I'm Dave Norma, and until next time.